Hi, in this video I'm going to show you how to apply the sampling distribution concepts for problems, real problems, and how to solve them in Excel. So how can we apply these concepts? We can estimate the probability of our sample mean be close to the population mean. Let's take a look at one example. Here's the EAI employee data again. Um, let's suppose the personnel director believes that this believes the sample mean will be an acceptable estimate of population mean if the sample mean is within 500 of the population mean. So the personnel director wants to know what's the probability that the sample mean be within 500 of the population mean. So that's the question. What's the probability that the sample mean computed using a simple random sample of 30 employees will be within 500 of population mean? Okay, so here's the example in the steps to solve this problem. So step one, the first step is you have is to define if the population is finite or infinite. So to do that, you compute the this like ratio of the sample size over the population size to determine if you need the correction factor. I want to make a clarification. Let me go back to this video. So you use this population, finite population, when the ratio sample size divided by population size is higher than 0.05. Okay, let me uh, stress this point and correct this point here. Okay, so you use this formula, the finite population formula, if the ratio sample size over population size is higher than 0.05, then you use this formula. If this ratio is smaller than 0.05, this finite population is treated as being infinite. Okay, this is really important because this is the first step to solve this problem, is compute this ratio. Here the sample size is 30, the population size is 2500. If we divide this 0.0112, 0.012, so this is smaller than 0.05 because it's 0.01. So we treat this population as infinite, so we can ignore the finite population correction factor. Okay, so now we know which formula we're going to use in step 2 to compute the standard error of the mean. So the standard error of the mean is computed using the infinite population formula, which is the sample size given in the problem, which is 4,000, divided by the sample size of 30, also given in the problem. So the standard error of the mean using this sample size is 730.30. Step 3 is to compute or calculate the upper end point of the interval. The upper end point is the population mean, which is given in the problem, plus the desired value also given in the problem, which is 500. So I add 500 to the population mean to get the upper end point of the interval, and I subtract the desired value of 500 from the population mean to get the lower end point. Now I have the interval, okay? Because I want to know again what's the probability that it will be within 500. So within 500 is plus and minus 500 of population mean, which gives us a range, an upper and lower end point. Let me show you that in like, it is here. Let me see if it works. Let me refresh the browser. Get my, let me try to see if I can connect again. No, hold on. Okay, I'm back. Now it's working. Now let me go back to the problem. So the problem is, let me draw here. So we have a distribution. I have a population mean, and I want to add and subtract 500 because this is what the personal director wants to figure out if our sample mean does a good job in including the population, or how much of the population mean it includes. So we subtract and add 500 of population mean. So this is the interval I was talking about. We have this interval because we added and subtract. What we have to do now, and what we're really doing, is we're computing the probability in the center, because this is what the problem is talking about. This is what's the probability that the sample mean computed using a simple random sample of 30 employees will be 500 of the population mean. Okay, so this is be within 500 of the population mean. 5 less and 5 more. We add and subtract, and this is the area we're going to compute. So these were the steps. First, you compute the need for the correction factor using the ratio that I showed you before. And then you compute the standard error of the mean. Now you compute the upper and lower endpoint like I showed you. And then you can use the Excel functions you learned in chapter 6 to figure out the areas. Let me show you here one more time. So what we are doing is, first, remember we did that in chapter 6. First, we're going to compute the probability up to 52,300, and then we're going to compute the probability up to 51,300. Okay, and then we'll subtract this probability and this probability, subtract, and that's the final answer. Okay, so this is how you get those areas, those probabilities. Like, this is the draw, the chart I made for you, and then you subtract the areas. Let's do that in Excel so you can see how to do that. Okay, so let's go back. First step, step 1. Let's call it step 1. Okay, this step is determining the need for the correction factor. So I have my sample size. Let's call N is big N. My lower capital N and my big capital N, which is 25. So this is the sample size. This is population size. And then the ratio N divided by N is equal to 30 divided by 2500. So if I'm, this is smaller than 0.05 because this is less than 0.05, we don't need the correction factor, and can use the infinite Okay, so this is the first step. Step 2 is computing the standard error of the mean. To compute the standard error of the mean, you need the standard deviation, which is 4,000. That's given in the problem. And you need the sample size. Sample size is over there. So to compute, what we do is the formula is standard deviation divided by square root of n, which is equal to the standard deviation divided by open parenthesis square root. I don't need the square root of the sample size, which is here. You can type or select the cell. So that's 730 like we have on slides. Okay, step 2 is done. Now step 3. Step 3, compute the upper and lower level. So the upper, it's 52,300, we computed before. So you add and subtract 500 from the population mean. Population mean is given in the problem is 51,800. So if I add and subtract, these are the upper and lower levels of the interval. So step 4, we're going to compute the areas for the upper and lower. So this is norm.dist. This is the first interval. The mean is 51,800 given in the problem. The standard deviation is this standard deviation here. This is the standard deviation of the mean, not this one, and then type 1. Then for the lower, norm.dist, the mean is standard deviation is the standard deviation of the mean. We type 1. Now finally, step 5, final answer is equal to this upper minus the lower, which is 0.5064, 0.5066, that's 64. Okay, so this is the answer, the probability. So the final answer is the probability, the sample mean computed using a sample random sample of 30 employees is that will be within 500 of population mean is 0.5064. Okay, so this is how you solve this problem and use the concepts of sampling distribution to get information about the population mean.